Thank you very much. Thank you for me being able, for inviting me and me being able to see Sofia for the first time. This is Sofia, right? Yeah, I'm really enjoying myself here. It's a great city. The weather is great. I mean, what else can you wish for? Yeah, so my name is Jan. And when I don't do artsy things with Ruby, I run a company together with a friend that is called DebFoo. This is why I'm wearing a t-shirt that says DebFoo on it. If you haven't heard of it, it's a pretty great service that automates dependency updates for Ruby projects, and we are also doing JavaScript by now. So you get pull requests on your GitHub projects for dependencies that get updated. It's free for open source and private repos, so if you want to try it out, please give it a try. Let me know what you think. If you want to talk about dependency management, dependency updates, please come to me afterwards. I also have stickers, and that was the advertisement block. Before I start with my talk, I need to warn you about something. So, this might be a bit weird, but this is a presentation full of code, and I don't want you to try too hard to understand what's going on. And the reason for that is that it's really a lot of code with from very different projects. Whoa, that was quick. It's kind of this thing where you I want to show you some ideas, but I don't want to explain everything in detail. And actually, there's a GitHub repo with all the source code. I haven't pushed the current state yet, but I will be after my presentation. And so please don't try to understand the code examples. If you nice. So yeah, I'm going to continue now. Don't be too hard on yourself if you don't understand anything. That doesn't matter, you can read it afterwards. So I want to start with 2D graphics. So we're going to start with graphics, and then I'm going to do something with sound as well. And the first thing is offline generation of graphics. And the example I have is more or less a kind of illustration why I do these things and why these projects happen. So I have a project on GitHub called Calgen, or Calgen, whatever you want to call it, and it just does calendar sheets. So the backstory of this is that for reasons that are not known to me anymore, my mother gets a calendar with the best photos my girlfriend and I shot over the year. Every Christmas, she gets 12 new calendar sheets for the next year with the best photos. And when we started with this, I had a new printer, and it came with this software to print calendars, and it was meant to be you drag in the photos and then you print the calendars, but I just printed empty pages with the calendar sheets on it and then put real photo prints on them. And that was really nice. It was very configurable. You could change the fonts and everything, so I could design this to my liking. And then my printer kind of broke down, as they all do. And I got a new printer. And obviously, with every of those bundled software suits, the software wouldn't work with my new printer because it's kind of hard-coded to the other printer, which broke down. And I tried a lot of software, lots of different things. There's trillions of programs on the Mac App Store to do something like this, but I couldn't really find something that was doing exactly what I wanted it to do. And so at some point I just decided, well, this should be an easy to fix thing. And I created a program that just creates beautiful calendar sheets, very minimal, exactly the way I liked it. If you don't like it, that's okay, but I like it, my mother likes it. And I'm using Prawn for that. How many in here have worked with Prawn? Right, a couple of people. So Prawn is a library that allows you to create PDFs. And it's written by Alexander Mancuta and many others. And it's relatively easy to work with. This is just a small part of the program, and what I like about Prawn is that it almost, like, because that's the way PDFs work, it's like very similar to working in a graphical, like, I don't know, Illustrator or something like that, where you have these bounding boxes and you can put text in them and you can align the text and everything, and that makes it really easy to create these layouts. So that's offline graphics, not really interesting, but it's like one of those stories about how these projects come about. The first thing I want to talk about is 2D kind of vector graphics. How many of you know this book? Okay, one person over here. That's a hanging hand there, right? This used to be a German book called Generative Gestaltung, and I think it's now only available in English, unfortunately. Unfortunately for the German market, fortunately for everyone else. And it's one of those rare books, actually the only one that I know, that is both a coffee table book, it's really beautiful to look at, and it's a book that teaches you how to code. And that's like a very rare combination. So it's really beautiful, and it teaches you how to use processing. So how many of you in here have used processing? A couple of hands, that's good. So processing is cool. It's like this 2D graphics prototyping thing, but it's Java. And I don't know about you, but I don't hate Java per se, but I also don't really love it. I mean, one of the reasons I'm doing Ruby because I ran away from Java. So yeah, so there's this thing called JRubyArt, which is one of the predecessors of a thing called Ruby processing, and it's written by Martin, or currently maintained by a guy called Martin Prout, and it's pretty cool. So it allows you to do basically the same thing you can do in processing, but allows you to use very beautiful Ruby code. And this is an example, a very simple program. So you have event handlers for pressed keys, for mouse buttons and everything. And this is the draw method, and this gets called like every frame, and so you can draw something there. And I'm going to show you how this looks. This is going to be interesting with a microphone. Wrong program. So this is running JRuby, obviously. So it takes a while to boot up and then gets really fast after 30 minutes or so. So this is a very simple program, but it's already like showing the power of these generative art things, because it's like there's so many designs you can figure out with this thing. If I click the mouse button, it changes the random seed that generates these things. And it's the only thing that happens here is basically it's dividing the thing up into a grid and then randomly decides if a line is drawn like this or like this. And this is all it does. And you can change the line endings with key presses. So suddenly it looks a little bit like this. And by changing the mouse position, you just change the thickness of the lines in certain directions. And that's one of the first examples in the book. And I just kind of converted it to Ruby, and I think it's a beautiful example because it's so simple and so effective. The next one is a bit more complicated. So this is at the end of the book, and it's a partially converted sample. Takes a while. I hope it boots up. So this is a sunburst graph. It's a bit hard to see in the back, I guess. I can't do it full time, but this is actually a Rails app. And it shows the file structure of the Rails app and the sizes of the different files and like the hierarchy behind it. So these are the services, and yeah, so this is like I said, it's a very simple example. There are a couple of things in JRubyArt that that are not working if you try to convert them from processing. Like I can't change it to another folder that's hard-coded right now. But you can see that it's a pretty awesome visualization for something, and it's relatively easy to do that in JRubyArt. So the next one is Gosu. Who in here has tried Gosu before? Okay, a couple of people again. So Gosu is a library by mainly Julian Raschke, and it's a library to build games. So it's a C++ library with Ruby bindings, and it's built on top of OpenGL and the obvious stacks. So Gosu looks sort of similar. You have a draw method, and then you have event handlers for button presses and everything. And this is part of a program that I'm going to show you now, which probably looks sort of familiar to you if you are as old as me. And this is only and this is only a couple of hundred lines of code, and it's really nice to build these kind of things. It's super smooth, and you can write games in Ruby, and that's awesome in itself. So yeah, I have another Gosu example later on that looks a little bit better, but in that case, the looks are actually not important. But yeah, you will see that later. Okay, so. So let's talk about 3D graphics. And 3D graphics, there are OpenGL bindings for Ruby and OpenGL in itself. Like, how many of you in here have experience with writing OpenGL stuff? That's a very easy to understand API, right? Sorry. So yeah. So there's this thing, this library called Mitsu, and Mitsu is written by Daniel Smith, and it's inspired by 3JS, and 3JS is an awesome project that wraps WebGL, the OpenGL version that runs in your browser, and 3JS has done a really great job in simplifying these really weird very low-level APIs into something that is actually understandable, relatively easy to write 3D programs with it. And Mitsu just takes a page out of that book and basically converted the API to Ruby. And so 3D stuff is always more complicated than 2D stuff, so this is more code, but well, you have to set up a renderer, and then you have to set up geometry and materials and everything. A camera and lights probably, and this doesn't even have lights. This is the hello world of 3D programming. Let me show you what it does. It's really impressive, I can tell you that. So this is a cube. It's sort of hard to see, and the reason it's hard to see because, like I said, there are no lights and there are no real materials. So what you see is a spinning box, but it doesn't look like one, which is interesting. So let's see if we can find something else that is a little bit more accessible. And I actually did a special version of this. So this is just using some sine waves and a little bit of binary decoding and so on, and it's still 150 lines of code or something like that. So it's really not that much. And I've loaded in the Ruby thing. I found it somewhere on the internet, and I think this is kind of nice. It needs some music though, but it's kind of nice. Yeah. So this is Mitsu. Now. All this scrolling. So the next thing I want to talk about is SketchUp. How many of you have ever worked with SketchUp? It used to be Google SketchUp. Okay, a couple of more hands on as soon as I mentioned that. So SketchUp is a 3D program, a 3D editor, which is unfortunately no longer available in a free version. Well, it is, kind of. The last year's version is available as a free software. And the cool thing about SketchUp is that it does have a Ruby API. And about, I would say, something like 6 years ago or so, I wrote a couple of articles for a German computer magazine on how to use Ruby scripting in SketchUp, and so I thought it might be nice to include that. Now, keep in mind, again, it's like there is a free version. It has lots of limitations. For example, you can't really export good 3D objects from it in like a good format. Luckily, you can fix that because there is still a free version that runs in a web browser, and you can import the models from the free version, which is from last year, and then export them from the web version. I have no idea why companies do stupid stuff like that, but it sort of works. The SketchUp API has a couple of things. So this is how you would display a dialog to configure something, and then you have then you can basically set up a model definition, and then you create. Then you basically create a 3D object from scratch by generating points, and yeah. So this is how you would create a cube, and now we are going to take a look at this. So I have two things. Haven't even started SketchUp. That's a bummer. There you go. So I have this extensions menu. Sorry for the German text in there. And I have two functions that I've built. One is called pixel ground, and I have to input some magic values in there. And now I have like a randomly generated pixel ground. So every cube is like slightly shifted. I don't know if you can see that. Let me get that a little bit bigger. And now I have a pixel ground of sorts, and now I have this pixel text thing, and basically uses the same sort of characters I showed you earlier. And let's put the same text in here. I'm just reusing that weird paragraph character there to display something much nicer. And now I can put this on top, and suddenly I have a 3D object that is kind of nice. And one of the reasons you would want to do something like this is because we have these things called 3D printers. How many of you in here have a 3D printer at home or have access to it? They're pretty awesome, and they've become really, really cheap over the last few years. And so I got one. And so I brought something, which is the physical representation of this. You can just like give it around. It's not a very good print, so if you look at it, the quality is really shoddy because I had to print it in a hurry, and I wasn't able to kind of properly calibrate the printer, which is a bummer. But this is, I like this idea of like you create something with software you wrote yourself, and then you turn it into a physical object. I really love that idea. So that's SketchUp, and when I did this the last couple of times, I was like, yeah, but it's a free version, and I'm always like adding all these caveats, how this software really is not any more available, and so I was thinking like, how could I do this in a different way? And there is a standard object format for 3D stuff, which is called wavefront. There's a T missing there. I will fire my editor. Let me get him on the phone. And so yeah, it's called wavefront object, and it's basically a human readable format to describe 3D objects. And there's now a gem called wavefront object, written by Stefan Kracht, and he also wrote a pretty cool blog post about it, I think in 2013 or 14. And the format is a little bit complicated. So this is how you actually create a cube. So a cube has 6 sides. So every face of the cube has 4 points, and so this adds up to this weird method, but it actually works. And so you create a wavefront object. It's like a really simple gem. It's like a couple of like 100 lines or so, even less. It tries to be clever with what it actually saves to the file to prevent duplication and everything. But apart from that, it's really just you have points and then you add faces to it. And yeah, so I have a very impressive demo on this. Because, yeah, Ruby cubes. Woohoo! Okay, let's make this at least a little bit more impressive. So, sorry. So this is basically the same thing as I showed you earlier. But it's like, I don't even need the 3D editor. I can just generate something with code. And this would be 3D printable as well. So yeah, this is pretty cool. Don't ask me how to do more complex stuff with it, because I'm not a 3D expert. But cubes are simple, so I'll probably stick to cubes. Okay, so let's get to the music and sound part. And this is where where my heart is living, so to speak. And the first thing I want to show you is Sonic Pi. So how many of you have played with Sonic Pi or did music with it? Great. A lot of people, that's good. It's a project that I really want to see mentioned more often. It's been conceptualized by Carrie Ann, who's a teacher, and Sam Aaron is the main programmer behind it still. He does all these workshops with it, and he also does gigs with it, and it's pretty cool. So all of what he does is probably way more impressive than what I can do with it. But let's see. So this is sort of the hello world. It's a bass drum. It's not nothing. So you have a loop. You play a sample and then you sleep for half a beat. So the sleep thing works kind of differently than it does in normal Ruby, because it's dependent on the tempo of the song. And this is a weird thing here. Let's add a melody to that. It's a very crappy melody. You've been warned. So this is just the very basics of what you can do with it. So let me show you something that I did recently. I'm not going to play it in full, but it gives you probably a better idea of what it actually can sound like. And so on. All right, so yeah, that was Sonic Pi. So if you haven't checked it out yet, it's really great, and it's also a fun way of learning programming with kids, for example. It has like the best online help ever. It's really great. So when I first did this, I thought, well, yeah, that's cool, but let's go to the basic principles of making music. So this is a non-project called Ruby Synth, and so the idea is to use Ruby to generate some audio and then somehow send it to the sound card and have fun with it. Now, the second part is sort of the complicated thing because, I mean, Ruby can do some mathematics stuff, so we are probably able to generate sound somehow, but how do we get it to the sound card? And one of my favorite open source projects of all time is Socks. How many of you know Socks? Okay, one hand in the back, great. Socks is, I think it stands for Sound Exchange, and it's originally written by Lance Norskog. I hope I get that right. It's currently maintained, I think, by Chris Bagwell, and it started in 1991. Let that sink in for a minute. And many people did contributions to that. And what it is basically your Swiss Army knife for audio conversion. So you can, if there's an audio format out there, Socks knows it. So you can convert everything from anything. And the cool thing is that Socks comes with another, like the normal command line thing is called Socks, and then you have also a command called play, which has the same conversion logic inside and then just puts it to the sound card. And if you use exactly these parameters I'm showing you there, which is raw format, so we don't have to send any headers, 32 bytes, 441 kilohertz sampling rate, one channel, floating point format, and little endianness, then you can actually use Ruby to pipe stuff into it by just using pack, which is a pretty neat thing to do. So you just have one command line utility that outputs floating values in this very specific format in binary. You pipe that into Socks, and you end up with sound on a sound card. But the question now is, what kind of data do we actually send? So the question is, my question for you is, what would be the most simplest waveform I could generate with Ruby to output with this? Any ideas? Just shout at me. Sine wave? Nice idea, completely wrong, but yeah, nice idea. It's really great because every time I have given this talk so far, the first answer is always a sine wave, but if you think about it, it's like really complicated. You have to figure out the period of the sine wave, and then you have to kind of calculate with the rate. So there's something much simpler. Silence. Yeah, that's good as well. Think even more simpler than silence. What was that? Linear. Yeah, that's also a good idea. You're thinking way too complicated. What? Yeah, highs and lows. That has a name. It's called a rectangle. And this is how you generate a rectangle. So you just have to do some calculations with the sampling frequency and the frequency you actually want to generate. And then at half the period, you just switch from high to low. And then you're done. It's like, yeah, it's a rectangle. And what is this? So I'm going to show to you how this sounds. I'm sorry, this is, so I've wrapped the whole thing in a little shell script, but it basically does the same thing as I showed you earlier. And I'm going to make this very quiet because it's, let me do that again because it's so fun. So this is the rectangle at the standard pitch, 440 hertz. Wait a second, this is not the correct one. And yeah, that doesn't sound really good, does it? So it's also distinctively non-musical because it's just, well, it's a tone. It would work as some sort of alarm thing, but apart from that, it's probably not good. So now it gets slightly more complicated. So I have some notes over there, and these don't look like musical notes to most of you probably because there are no C's and no G's and no D's and no sharps and whatnot. But these are so-called MIDI note numbers, and MIDI is a standard. I'm going to talk about it later on, and it's basically, so you start with a 0, which is a very low C, and then you have 12 halftones, so the next lower C would be 12, and then you have 24, and so on. So 24 is actually a C as well. And I'm doing some that wasn't good. I'm doing some calculations here and trying to turn it into a melody. Let's see how this sounds. It sounds a little bit like the 80s, but it's actually, now it starts to sound like music, right? So that's pretty good. Let's add some magic. So I have no idea how this works. I have never looked at it in detail, but it is there's this awesome website called musicdsp.org, which is the complete archive of a mailing list that has been running since the early 90s or something, that just basically contains all like open source DSP code you can think of. And this is one thing I converted from C++ or something, which is a filter. So what does a filter do? If you think about this in a way that you have the frequency spectrum here, and you have a filter curve that looks a little bit like this, so you cut off the upper half of the sound, and that's what's called a low-pass filter. And the specifics of this so-called Moog filter, or Moog filter, is that it kind of feeds back the output into the input again a little bit, and by that it creates a resonance around the cutoff frequency, which you probably know as this kind of weird squelchy sound in techno music. And yeah, so to incorporate this into my little synthesizer thing, I'm just letting it run over the values I'm generating, and that sounds like this. And this is already much nicer, right? This is less harsh and sounds a lot more like a real synthesizer. Let's add one more thing to it, which is a so-called envelope, which is used in synthesizers a lot. What it means is that you shape the sound over time, and could look like this. So this is a very simple attack and decay envelope. Usually those have more stages. So you can fade in something and then you can fade it out again. And I am using that for both the filter and the volume. So the sound is going to fade out, it's going to be quieter, but also the filter frequency is going to change over time. And if I do that, and this is already like, this is Berghain techno. Just add a bass drum to it, done, thank you. Off the stage. My job is done here. Let me play it again. So yeah, this is how you can create audio stuff in Ruby. It's like a very small project. You can take a look at it. It's not a lot of code, and I think it's kind of fun to explore it in this detail at least once. Kind of side note at this point. I'm a big fan of the Web Audio API, which is a thing that is in Chrome and Safari and most browsers these days, actually. Even IE has it. And it's sort of an API that sits on top of what I just showed you. So there are oscillators, there are filters, there are amplifiers, and you can kind of connect them into an audio graph, and then you can modulate them over time. And so you can actually, in your browser, with just a little bit of JavaScript, you can actually build your own synthesizer, which is pretty fascinating. If you want to know more about that, please come to me afterwards. I'm preparing stuff for next week's JSConf in Berlin because I'm slightly terrified because I have to play music there. So yeah, this is really great. It's not Ruby, I know, but it's I love it. Let's talk about MIDI. I mentioned it briefly. MIDI stands for Musical Instruments Digital Interface, and it's from 1983. How many of you are born after 1983? Well, not me. So this is pretty cool thing that exists since the 80s, and it's still in use. Most of the time, it used to be. So, how many of you recognize this shape? Okay, enough people. That's good. Probably the other half. So this is a so-called DIN plug. It's the official way how to connect synthesizers. It's part of the actual MIDI standard, the hardware implementation. And it's pretty cool. It's a serial connection. It's very stable. It's been invented to be super stable under stage conditions. It works really, really well, and still most of the people use this nowadays. So you probably recognize this, and most of MIDI data nowadays is actually going to come over USB, or even it never really leaves the computer, because MIDI is also used for internal communications for a lot of music software. So a MIDI message, like I said, it's a very simple serial protocol, and a MIDI message could look like this. So it's really just 3 bytes. If you're looking closely, you can see, obviously, to me it's obvious, that the first byte has actually the highest bit set, and the other 2 don't. And that's exactly how MIDI works. So you have command bytes, which have the highest bit set, and then you have data bytes, which don't have the highest bit set, which also means that you can only transmit 7-bit data over MIDI. It's not entirely correct, but like you can only transmit 7-bit bytes, 7-bit values. And this is a message that would be sent if you have a keyboard and you press a key. So it's a note-on message. The lower half of the first byte is the channel, so you have 16 channels. 0 is the first channel. And the next one is the note. That's the note values I've been talking about earlier. And the last one is velocity. This is basically how hard you hit the key. And yeah, and you just send these things over the wire. And how would you do that? There's a great open source library that tries to be as cross-compatible between different platforms as possible. And I actually wrote some Ruby bindings for this. So you just start the port MIDI system, and then you have to query the devices, because every device you connect to your computer will show up as a named device, and you have to kind of make sure you get the right one. I'm using IAC here. This is on Macs. This is sort of a loopback device that allows you to send MIDI out and then have other programs receive that. And then I'm just doing weird things here to send some notes over time and make them like time them in the future and then send them out in the right order and at the right time. And yeah, so this is the melody and the beat basically. And let me show you how that sounds. So let me show you briefly what this is. So this is a software that simply receives MIDI, and there are 2 synthesizers here. One is a kind of analog synthesizer, and this is a drum machine. Does this make sound? No, it doesn't. And then I can just use my command line again, because I'm so... And... So it's not great music, but you can kind of imagine how this would work if you have a professional musician writing your code. What? So yeah, this is what you can do with MIDI. And then there's this other thing which I have lying around here. So this is a launchpad. Short disclaimer: I'm currently working as a freelancer for the guys who do this, Novation. But that's not the reason I'm showing it. I had this before I started working there, so It's just a great device. You can think of it as just a button matrix with LEDs behind it. And what you do with it is completely up to you, and you use MIDI to, so it sends MIDI messages. It's just sending that to the same synthesizer. And it also receives MIDI messages and lights up the LEDs. And I have a very simple demo here, which is probably not worth much. There you go. So this is now just lighting up the LEDs when you press them. That's very impressive, I know. But you can see, like, one of the things I always wanted to do is have your test run actually appear on this, like red and green LEDs. That would be pretty cool. So the gem I'm using here is working on top of port MIDI. It's written by a colleague of mine, Thomas, and this is what the code looks like. And now I have one last demo and then I'm done, which is bringing a little bit of this together. So I have a demo. I need to remove that synthesizer because otherwise that's going to be very loud. And where am I? There you go. So you all know Minesweeper, right? Yeah. Wouldn't it be cool to play it on something like this? So this, I need to put away my microphone. This actually works. It will be really embarrassing because I suck at Minesweeper. So if you want to play this, give me a shout. I'll be here all day. I can show it to you. You can play it. And yeah, so this is I just took a Gosu version of Minesweeper and hacked it in there. So that's what I did there. So I don't really have time to go into the detail why I'm doing all this stuff, so let's skip that and say thank you very much.